Hello and welcome to part 2 of Radioactivity. If you haven't watched part 1 of Radioactivity, where I have introduced what is radioactivity and so on, please ensure you watch that video before you watch this. So in today's video, we're going to look at radioactive decay and half-life as a subtopic, and we'll define what is half-life. So half-life is the time taken for a given mass of radioactive isotope to decay to a half its original mass. Okay, for this case I'm going to use iodine 231, which initially the original mass was 400, and then in 8.1 days it went to 200 grams. In 8.1 days again it went to 100 grams, and finally the third time, 8.1 days, it was 50 grams. So that means it was breaking into a half of it and a half for those three. So we finally, from 400, we are at 50 grams in 3 half-lives. So one thing you need to note is that you can use the formula to calculate remaining amount of mass if you cannot do or relate this way. So the formula I've devised here is that remaining amount is equal to 1 over 2 in brackets raised to power n times the original mass. So I want us to try to calculate that using this particular question. So in this case, we're going to apply the formula. So the question says that the mass of m grams of an isotope, a radioactive isotope, decay to 5 grams in 100 days. So the half-life of the isotope is 25 days. Calculate the initial mass of the isotope. Okay, so I'm going to write the formula here is that the remaining amount equal to 1 over 2 in bracket n times original mass. So we have the remaining mass as 5 grams, and we apply the formula here where n will be 100 over 25 times now the original mass. So 5 is equals to 1 over 2 in brackets 4 times original mass. So that will be 5 is equals to 1 over 16 times original mass, which the original mass will be 80 grams. Okay, the original mass will be 80 grams. So that's how you can be able to calculate the radioactive decay and get either the initial amount of grams or any other of this using this particular formula. Okay, so I want us to look at nuclear reactions. We have different types of nuclear reactions, and so when you're dealing with the nuclear reaction, for this particle of alpha, they are emitted both. So let's look at nuclear reactions. So when alpha particle is emitted, both mass number and atomic number changes to give a new nuclide. For instance, helium, it usually actually releases helium. So the mass number decreases by 4, while the atomic number decreases by 4, while the atomic number also decreases by 2. So for instance, proctanium, which is 233, emitting an alpha particle to form actinum of 229 as a mass number. So this is the equation here. As you can see, it was able to emit helium. Now for beta particle, when beta particle is emitted, atomic number increases by 1 while the mass number remains constant. For instance here, so the mass number has remained constant, but the atomic number has increased by 1, and emission of a beta particle. So, and it can also be related as this. So this actually does release by increasing the proton, and this particle is released. Okay. Now, I want us to define two terms. One of it is nuclear fission and nuclear fusion, because these are terms that you can really meet them in an exam. So what is nuclear fusion? It's just the splitting of a heavy nuclide when bombarded by a fast-moving neutron, while nuclear fusion is the combination of light nuclei when made to collide at a high velocity. So thank you so much for watching. Ensure you like this video, give it a thumbs up, and subscribe on this channel if you are getting any value in my lessons. Thank you so much. See you in my next lesson.